proceed. Okay, as for what I'm saying now, alright, Megan, Vanessa, Matthew, as well as Josh is not done. Okay, and then actually, I'm not done. Okay, I'm not sure what happened. Yes, okay, and then Sishuan is not here. Okay, but it's half done. Right? Regardless, I just want to run through some of the answers in the worksheet. Okay, don't worry, I'll upload this on Google Classroom for you to check through. Okay, this piece of worksheet is really for us to run through. Let me repeat myself. Okay, this worksheet is really for you to take note, okay, about what you saw on the SLS lesson itself. Okay, so for the introductory problem, it's really left up to you how you want to actually go about presenting your answer. There isn't really a right or wrong answer when it comes to the first column. Okay, if you don't do by matrices. However, when you do by matrices, you realize that it is much easier. And that is the whole purpose of us doing matrix itself. Okay, it makes our presentation of answer much more orderly and neater. Okay. Now, I want to run through, okay, these 4 points that are found in the worksheet. Okay, these 4 bullet points. Now, let me just zoom in. Okay, these are terms that you need to be familiar with. Right? The very first one is that a matrix with one column is called a column matrix. Okay? So some column matrix that you will have are things like this. Okay? It is one column only, 1, 2, 3, 4, 5. The elements really don't matter. Okay? However, there are 2 column matrices that are rather important when later on we look at problem sums. Okay, that will be a full column of zeros and also a full column of ones. Okay, so depending on the question, again, it can be of different order. So you can have a column of 1, 1, 1 or 1, 1, 1, 1, 1. Okay, really depends on the question. Okay, so these are quite useful. Alright, when we do our problem sums. Likewise, we also have a row matrix. Okay, whereby we have 1, 2, 3, 4, 5. They're just really random numbers. Okay. Then similar to column matrix, you can have a single row, okay, of zeros or a single row of ones. Sorry, let me okay. So just some examples. Okay. So column matrix and row matrix is only one column or else one row. Okay. So this brings us to also recap what is an order of a matrix. So matrices need not always be square. Okay, I hope that you did take note that the things found inside the matrix are elements. They cannot be separated by any comma, so no commas to be found. Likewise, no fraction line. Okay, so because of habit, sometimes people will draw a fraction line or they actually put comma. Okay, so make sure that your elements are sufficiently spaced apart. Some of you have handwriting that are so small it tend to be placed together, and that will actually cause some errors when you do your calculation. Okay, so rows itself are seen horizontally. Okay, so those are rows, and then after that vertically you have your columns. Right? So you can think of columns like, you know, you have your pillars. Okay, so in construction your pillars are also called columns. Okay, so columns are vertical. In case you cannot get around with understanding these 2 words, rows and columns. Okay. So in this particular case for matrix A, it is a 3 by 2 matrix. It is an order. So we read it as 3 by 2. We don't call it 3 times 2. Okay. Then please don't tell me that the order of the matrix is 6. Okay. Then you go and multiply that. No. Alright. So you come with the number row first, followed by the columns. Okay. Then we also have this thing called a square matrix. I realize I just missed out on one bullet point. Okay. So square matrix are quite unique and meaningful as well. Okay, they serve certain purposes. This one I'll talk more about it. Okay, so square matrix have the same number of rows and columns. That's why it is called a square. Okay, so you can have elements such as this. Okay, here are just some examples. And then there's this very unique one. Okay, whereby the diagonals are ones and then the other numbers are zero. Okay, so this is a 2 by 2 identity matrix. Okay, I will talk more about identity matrices later on. Okay, questions? Right? So we covered column matrix and also row matrices already. Okay, next thing is about this thing called zero matrix. I realized in my editing of the worksheet, I forgot to cancel out one line. So let me just make this full screen. View. Screen. Sorry, Okay. So there's this thing called zero matrix, or sometimes we call it a null matrix. Okay. There is no formal notation when it comes to zero matrix. However, you will notice that textbook usually uses a bold zero. Okay, we can only do that in printing. We cannot do that in writing. Okay, so sometimes textbook will use a bold zero to actually represent a zero matrix. Okay, but this is in printing only. Not applicable to writing. Right? In case for some of you, which I'm also aware, okay, you have already covered vectors. Okay, so later on when we go into chapter 5, okay, we do have our vectors written with a tilde sign at the bottom, but this one is really to represent a zero vector only. Okay, so vectors are not your matrices. Okay, so just in case for information, okay, for those that have are already aware about vectors, right? So you need to also differentiate, okay, this and this. So in case the back people cannot see, this is actually a matrix. It is in fact a 1 by 1 matrix with element 0. Okay, it is not equals to 0 itself, whereby 0 is just a number. In fact, we call it a scalar number. Okay. So in case you are multiplying two matrices or you're adding up two matrices, okay, for example, if maybe you are adding up two matrices 1, 2, 3, 4 plus -1, -2, -3, -4, okay, we know that it will come out to be a zero matrix, okay, which is like that. You cannot write for me that it is equals to 0. Okay, because this is a number, this is a matrix. Matrices and numbers are different concepts. Okay, so do differentiate your notation itself. Right? So zero matrices come in many forms. Okay, it can come in all sorts of order, need not be just these examples. Okay, essentially the elements are all zero. That's why it is called a zero matrix. Okay, so you need to use accordingly whatever order that is suitable to the question. Just like what I did over here, when two matrices here are 2 by 2, adding with another 2 by 2 matrix, the resultant must be of the same order, 2 by 2 as well. Okay, therefore I must fill up a 2 by 2 matrix with all zeros. I cannot write it as a single zero. neither can I simplify it to writing it as a 1 by 1 matrix, okay, with zeros inside. They are not equal. Okay, so we must ensure that the order is always maintained. Okay. Then, when it comes to equal matrix, just like the word suggests, there are two matrices that are exactly the same thing. Okay, all the corresponding elements are the same as well. Okay, the top left hand corner must match with the element of the other top left hand corner. The top right hand must match with the top right hand. Okay, this is provided it's a square matrix like that. Okay, otherwise, okay, if you change the order of the elements, okay, they are definitely not equal at all. Okay, likewise, 2, 3 and 2, 3, 0, 0, they are actually not equal matrices. Okay, because the order are different in the same place, and as mentioned earlier, okay, your zero matrix, while they are both zero matrices, the orders are different. Not sure whether can I scroll it down further. Okay, I cannot. Okay, this is the best I can do so far. Okay, so these are certain terms that you need to be aware about when it comes to matrices. Okay, any questions so far? Right? If not, I do notice that there's a homework that's due today. Okay, I forgot about it, so I forgot to write out my A-Maths textbook. Is it okay if I have this postponed to tomorrow? Can? Can? Okay. We postpone this exercise 15.2 to be submitted tomorrow. Okay? Can? You look like I'm asking for something very demanding. And okay. You seem to look at me like he wants to sleep or something like that. Okay. Okay, so with that, right, okay, with those being covered, I want to reinforce our ideas about matrices multiplication especially. Okay, if you had watched the video, you notice that the way they teach matrix multiplication is slightly different from how I would teach it. Okay, I tend to see it in a very I see in a visual manner, okay, like a roti prata kind of flipping kind of method. Okay, so what do I mean by that? Okay, so just to recap, how do we multiply matrices, and also for the benefit of those that didn't do the SLS, okay, matrix multiplication is very important. Okay, so step 1, we always check the order of the matrices. So we have two matrices over here. On the left, it is a 2 by 2 matrix, and on the right, it's a 2 by 3 matrix. Okay, so we must ensure that the number of columns of the left matrix, meaning to say this number here, must be equal, okay, to the number of rows in the matrix on the right. So they must be equal first in order for us to multiply. If the numbers are not equal, okay, then we cannot multiply any matrices. Okay, so you must do that check first. Then, okay, we will know the order of the product. Okay, so the order of the product will be this number of rows and this number of columns. Okay, so we figure that out, and then okay, you can go and draw in some space here to know that you're expecting a 2 rows and 3 column matrix. Okay, so in this case, I'm just going to represent it with this matrix itself. Okay. Then, right, okay, how do we figure out the elements in the matrix itself? So, for example, let's start with the first row, first column. Okay, that will be your top left-hand corner. So, this is the first row, this is the first column. First row, first column is to come from the left matrices first row and the right matrices first column. Okay, so always row, column, row, column. So always remember that. Likewise for order, row, column. Okay, so row here and column here. Alright, just now I mentioned about this roti prata idea. Okay, what I visually think about in my mind, okay, I think of taking this first row, I flip it around, okay, and I multiply 7 to 2, adding up with multiplication of 3 and 8. So I'm trying to think of this, I turn it around, I match the numbers, okay, multiply and add. Alright, so that's how I visualize it in my mind, okay, rather than I think the complicated ones that you might see in the video, okay. So therefore, P itself will be 7 times 2 plus 3 times 8, and therefore it is 38, okay. Lost it out.
Say thank you to nobody. The guy was like, thank you. You're not thinking at all right now.
Questions? Okay, so likewise, okay, if I'm trying to find out, let's say, first row, second column, okay, I will go for the first row on the left, second column on the right. Okay, so again, watch the animation. First row, flip around, multiply with the second column, and add. Okay, then Q will be 7 times negative 3 plus 3 times 1 itself, so negative 18. Okay, you really don't need to show the working itself. Okay, you can just press into your calculator. So that's why if you have this kind of mental image in your mind, you could just directly press into your calculator and get the number, then you write. Okay. Right? Then let's go for another one. Let's say, okay, this very last one over here. So go in a sequential manner rather than jump here, jump there. Okay, so go in an order. Okay, the final one, second row, third column. That means we will get the second row and third column. So again, we flip negative 2 and 4 with the 5 and 6. Okay, multiply and add, then we get 14. Okay. Right? So if you get the idea, okay, I want you, okay, to try and find out what is the value of R, S, and T, okay, using that same idea. Would I give you just 2 minutes, or actually 1 minute would be good enough? Okay, I'll just give 2. Okay, if you have 2 minutes, can you figure out what is R, S, and T? calculation. Okay, so as mentioned, you need not present the calculation. Why do I say that? Because our matrices as we move forward will not be of such simple orders anymore. Okay, sometimes you get very large orders, like maybe 4 by 3. Okay, then this calculation will end up becoming very long itself. Okay, so it is not quite feasible for us to present our work. Okay, and some more we have to leave space. So you can imagine, okay, especially some of you got very large handwriting, they end up you have no space. Right? So that's why we just press into a calculator. You should be able to get these values. Okay, so 38, negative 18, 53, 28, 10, and 14. Right? Okay, just in case along the way you forgot how to do matrix multiplication. Okay, I have already placed this animation online onto Google Classroom. It will be available at the end of our lesson 3 o'clock. Okay, however, because I'm placing it on Google Slides, the animation don't quite tally very well. Okay, so I try my best to give a compatible animation for you. Okay. Alright, so that's for your matrix multiplication. I want to go through this question from your SLS lesson. I have seen some of your answers. Oops. Okay. So this question talks about Juju and BB are two teams competing in the soccer champion league. The matrices below represent the results of their matches and points awarded to them. Okay, and then we have to explain what do the elements in the matrix of their product actually represent. Okay, so in order for us to know what the elements represent, which is a common question to be asked about. Okay, so we look at how is it being multiplied and added. Looking at the matrix multiplication over here, okay, we know that we have 2 multiplied with 0, 1 multiplied with 1, and 3 multiplied with 3. And what do the numbers actually mean? 2, 1, 3 is the loss drawn won for Juju. And then after that 0, 1, 3 is the points. So 2 losses multiplying with the point 0, adding up with 1 drawn and multiplying with points 1, okay, and 3 won and 3 points for winning. Okay, that will actually result in 10 points when adding up. Therefore, okay, in phrasing our answer, we can say that the elements in the matrix represent the points that Juju and Bibi received respectively. Okay, so to be more efficient in terms of writing our answer, we tend to use the word respectively. Okay, so rather than have to point out 10 represents what, okay, and then 0 represents what. Okay, because if you do that, right, if my elements, okay, this out to become a lot of it, it will be very tedious to actually write. So you just briefly describe and then use the word respectively. Okay, that will give you a shorter way of writing your answer. Okay. Questions so far? Right? Now, identity matrix, which is something not covered in our SLS lesson. Okay. Identity matrices are very important. You must first know that it is a square matrix. So I want you to write it down in your notes, either in the worksheet that I've given you, there's a lot of blank space, or in your notebook. Okay, so an identity matrix is a square matrix with its diagonal elements. Diagonal must be from top left to bottom right. Okay, not the other way round. So in this manner, okay, whereby this diagonal, the elements are all 1 and the rest of the elements are 0. So for example, we have a 2 by 2 identity matrix as this, and also a 3 by 3 identity matrix that looks like this. Okay, of course we can have a very large identity matrix, the n by n one. Okay, so long as the diagonals are always 1s, and then on the other elements, they're always zeros. Okay. What's so important about an identity For example, we know that 2 times 1 is 2, 3 times 1 is 3, okay, 5 times 1 is 5. So an identity matrix behaves like this value of 1. Okay? That means that whenever I multiply an identity matrix, okay, with any matrix, it will give us the same thing, okay, as a result. Okay. However, we must be careful. Not any order, okay, of identity matrix is suitable. So, for example, in this matrix with 2, -3, 5, -7, 0, 8. It is a 2 by 3 order. Okay. We know that the number of columns on the left must be equal to number of rows on the right. Therefore, this matrix over here for the identity, it must start with a 3. Okay, for its order. Alright, and since it is a square matrix, it must then be a 3 by 3 identity matrix. Okay, there is no other size or order, okay, that will actually be suitable. So it must be a 3 by 3 order, and therefore it is this matrix itself. And if we were to do our calculation, we take 2 times 1 plus this times 0 plus this times 0, they're all gone. So therefore we get a 2. Okay, and then after that we do the same for the rest. We will know that we're expecting a 2 by 3 matrix, and hence the result will be the same. Okay? That is for your identity matrix. Okay? And then the same thing applies. What if instead of multiplying from the right, I want to multiply from the left instead? Then the order, okay, may not actually be the same 3 by 3 anymore. Because for this matrix, it is a 2 by 3. So now that it appears on the right, okay, that means that the number of columns, okay, for this matrix on the left must be equals to 2. Hence, we cannot keep to a 3 by 3 matrix. We must use a 2 by 2 matrix. Okay, and that is your 1, 0, 0, 1. And hence we also get the same matrix as a result. Okay? Okay, can I move on? Yeah. Next one, very important. Okay, what if I present my matrix A square? Okay, this is a part whereby many times, okay, people get confused. Okay, we must know that A square is referring to A times A. So we're multiplying one matrix itself, okay, twice. Alright? So for example, if I have this matrix 2, 3, 4, 5, A square would mean that it is 2, 3, 4, 5 multiplied with 2, 3, 4, 5. And then we have to do our matrix multiplication where I get this row, multiply this column, add them up together, find all the elements, and the result of it will be 16, 21, 28, and 37. A very common mistake that people tend to make is to think that A square means that all the elements square each other, and that is not true. Okay, it is, if you square all the elements, it gives us 4, 9, 16, 25. And that is clearly different from the answer through matrix multiplication. Okay, so this is a common mistake that people tend to make, okay, when they see such notations. Just want to remind everyone about this part. And your SLS lesson, chapter 4.1 all the way to 4.3 we have covered already, okay? So I'm not going to do the questions that are found in 4.1 to 4.3. Okay, all the practice now questions all done already. As in all the concepts are covered already. Okay, so next half an hour, okay, I'm going to go into chapter 4.4. Alright? Because matrices really there isn't much to fully cover. Okay, it's all about addition, subtraction, multiplication. Okay, one thing you realize, okay, what about division? In matrix multiplication, there's no such thing as division. Okay, if you bring it up to when you're in JC, okay, the division equivalent of your matrices comes in this thing called this determinant. Okay, not discriminant but called determinant. Okay, but that one you will learn it, okay, when you pursue it at higher levels in future. Okay, that is the division equivalence. But there's no division when it comes to your matrices. Okay, in secondary school level. So we'll now go into our practice now 6 question 1. Directly tackling a problem sum like this. Okay, problem sums are very common when it comes to matrices question. So in this particular question, it says that Cheryl and Li Ting took a multiple choice test. The matrices show the results of the test and the marks awarded respectively. Okay, so part I is asking how many questions are there in the test. Okay, so how do we know how many questions are there? By looking at this X matrix here. Okay, what does it tell us? It tells us that there are 16 questions that were correct for Cheryl and 4 questions that are incorrect. So 16 plus 4 gives us 20, and that is consistent if I take 12 plus 5 plus 3. That is also going to give us 20. Okay, so therefore we can conclude that there are 20 questions in this test. Okay, so either working will do to tell you that it is equals to 20. Okay, in part 2, we are asking to evaluate xy. So that means we are multiplying the 2 matrices. So this is a 2 by 3 matrix. This is a 3 by 1 matrix. And our final matrix, okay, will have to be a 2 by 1. Okay, since the center numbers are the same, so we are expecting a 2 by 1 matrix. In other words, it is a column matrix. And that is by taking 16 times 2 plus 0 times 0 plus 4 times negative 1. Okay, keying that into your calculator, you will get 28. And like likewise, for the second row, first column, okay, we have 12 times 2 plus 5 times 0 plus 3 times -1. And that gives us 21. Okay. You need not write down the order, okay, in your answer. Alright, so you can just present the correct order, the correct matrix, that will be good enough already. Okay, so no need to write the order. Okay, very common, you will be asked to explain what the elements in the matrix actually represent. Then this goes back to how we understand the multiplication and the addition itself. Okay, so we look at taking the number of questions that were answered correctly, no attempt or incorrect, and multiply with the number of marks. This means that, okay, this element over here must represent the number of marks that Cheryl actually achieved. Or awarded to Cheryl. And then in the second element, it refers to the number of marks awarded to Yi. Okay, so therefore, in writing itself, okay, to be more succinct, we will say that the matrix or the elements in the matrix that refers to the number of marks that Cheryl and Yi received respectively. 新学可以 please wake up. Okay, a very typical question when it comes to matrices will look like this. Okay, so one question itself can go up to 10 marks usually. Okay, so it's a problem sum and you need to think carefully what kind of matrix to actually form, right, and how do we multiply the matrices. Okay, so not as straightforward as what we saw in question 1 itself, right? So I erase this one, can? Not yet? Okay, I'm seeing some of you still copying. Okay, so let's take a look at question 2. That's in your textbook, page 163, in case you can't see the one on the screen. Okay, sometimes the question could be very kind. They tell it to you, they present the information to you in a table. When they present it to you in the table, okay, then you can easily know what is the order of one matrix already. Okay, you just follow the format of the table. In this case, that will be a 5 by 4 matrix. Okay, so just follow the order, okay, rather than deviate. Very often you don't need to go about rearranging, okay, it will be very confusing itself. So in this context, it says that an otah factory produces 4 types of seafood otah. Okay, fish, prawns, squid, and mixed seafood. Okay, for distribution to 5 different outlets: Tampines, Bedok, City Hall, Toa Payoh and Jurong East. Okay? And then in part I, it talks about how each steak of fish, prawn, squid, and mixed seafood costs 35 cents, 40 cents, 45 cents, and 28 cents respectively. We want to write down two matrices such that the elements of their product under matrix multiplication give the total cost of quota delivered to each outlet. Okay, evaluate this product. So you need to be very clear about what the question actually wants in order to start thinking about how to form the matrix itself. Okay? So the objective of the question is such that you want the elements, okay, to give the total cost of quota delivered to each outlet. Okay? So the first question that you should ask yourself is, how many elements are we expecting? Okay, how many numbers or how many answers do we want to have at the end, okay, when you complete this question? Okay, so because we're looking for total cost of quota delivered to each outlet, right? There are 5 outlets in total. That means we are expecting 5 elements. Okay, so thinking question number 1, how many elements are we expecting in our answer? And in this case, there are 5. Okay, so that means that at the end of the day, when we have our final answer, we are expecting either a 1 by 5 matrix, or sorry, this one is a 5 by 1 matrix, or we have a 1 by 5 matrix, such that there are 5 elements only. Okay? It is not possible for us to form a square matrix or any other order. Okay? I cannot have like 6 blanks over here and then after one of them I don't fill up. Alright? So it is only either these 2 orders, okay, that we're looking at. Okay? Then the second question that you should think about is how would you normally get these values? Without matrices. Okay? So throw away the ideas of matrices first. Just think about how will you handle these numbers. What is the calculation that you will normally make? Okay? So in this case, for Tampines itself, we know that we will take 70 times 35 cents. Okay, plus 120 times 40 cents, then followed by plus 90 times 45 cents, and finally 80 times 38 cents. Okay, so this is the usual calculation that you will probably be doing at a very elementary level, okay, when you don't have matrices at all. Okay, so the same thing applies to everything. We are always thinking about doing this calculation. Answers. Okay, so you need to be very multiplication, the order is 5 by 4. Okay? Now it's either I multiply a matrix on the left or I multiply a matrix on the right. Okay? If I multiply a matrix on the right, it must be 4 by something. If I multiply a matrix on the left, okay, it must actually be a something by 5. Because the center numbers must always be the same. Okay? But we are very aware that our final answer must have 5 elements. Okay? So if I have a multiplication that is multiplying from the left, my final answer will be something by 4. Okay? And that will definitely not be a 5 by 1 or a 1 by 5 matrix. You follow what I'm trying to say? Okay? So if I multiply a matrix on the left to this one, it must become a something by 4. Confirm never fitting into the expectation. Okay? So therefore, doing a left multiplication to this one will not work. Okay? And therefore we look at a multiplying towards the right. Because I am going to expect a 5 by something matrix in the end. Okay? And I know that I want either a 5 by 1 or 1 by 5. In this case, it must be a 5 by 1 and this must be a 4 by 1 matrix. Okay? So the number of rows must be 4, okay, and 1 column itself. Okay? And since we're looking for cost and the things that we're trying to multiply are all 35, 40, 45, 38. Therefore, our 4 by 1 matrix must be 35, 40, 45, 38. Okay? And then we check our calculation. We take this times this plus this times this plus this times this and plus this times this. That is following exactly how we want our calculation to be. Okay? And therefore, upon multiplication, we will be expecting a 5 by 1 matrix, which is 14340, 16270, 12105, 15750, and a 10810. Okay, so that's how we get our 5 by 1 matrix at the end. 14,340. Okay, so in this particular elements, right, we see that 14,340 is actually in cents, because all these values are in cents. So depending on the question itself, okay, I will expect that they want to answer in dollars, okay. So therefore, please answer the question accordingly. Let me just zoom out. Okay, so therefore, the cost for Tampines, which stick on will be 143 dollars and 40 cents. Okay, right, divide by 100. Because the matrix is actually, the values are actually not entirely given for us to achieve what we want to find. Okay, so I'll go through part 2 and part 3 tomorrow at the start of the lesson. Then after I finish up already, I will then go into exercise 15.2 homework. Okay, sorry about this, I was too excited to want to teach the matrices today. Okay, so that's why I forgot about it.
Audio